Hello everyone. I am Revati, Assistant Professor of Chemistry in the Department of Humanities and Science. I am preferred from Applied Chemistry 2 for first year Mechanical Engineering. Course code CY25C03. To important fundamental knowledge and provide exposure to the application of chemistry in the mechanical engineering stream. To explore and understand the mechanisms and working principle of smart materials and smart coatings with emphasis on the real world engineering applications. The first one, functional materials. Functional materials are materials that are designed not only for structural support but also to perform specific functions such as sensing, energy conversion, or self-response to environmental changes. Types of functional materials: smart coatings, functional nanomaterials, energy-related materials. One important example is smart coatings. These coatings can respond to external conditions such as temperature, moisture, or light. Example: self-cleaning coatings used in building and solar panels. Anti-corrosion coatings used in bridges and pipelines. The mechanism behind smart coatings involves chemical reaction, surface energy changes, and nanoscale interaction. Another major area is sustainable energy materials such as materials used in solar cells, fuel cells, and rechargeable batteries. These materials support clean and renewable energy, which is essential for future development. The second unit, fuels. Fuels are substances that release energy throughout combustion. Classifications of fuels: solid fuels, coal; liquid fuels, petrol and diesel; gaseous fuels, LPG and natural gas. Most fuels are composed mainly of carbon and hydrogen. An important property of fuels is the calorific value, which represents the amount of heat energy released during combustion. Due to environmental concerns, there is a growing focus on alternative fuels such as biofuels, hydrogen, and compressed natural gases. Natural gas has many advantages, therefore high efficiency, low emissions, clear composition compared to coal and petrol. An important activity related to fuels is the comparisons of efficiency and emissions level, which helps in selecting eco-friendly fuels. And the next, composites. Composites materials are formed by combining two or more different materials to obtain better properties. A composite consists of matrix materials such as polymers, metals, or ceramics; reinforcement such as fibers or particles. Hybrid composites contain more than one type of reinforcement to improve strength and durability. Engineering applications of composites include aircraft structure, automobile components, sports equipment, and bicycles frames. One practical activity is the design of a lightweight composites bike frame, which improves performance while reducing weight. The fourth one, lubricants. Lubricants are substances used to reduce friction between moving parts in machinery. Types of lubricants include liquid lubricants, greases, solid lubricants. Functions of lubricants: reduce friction and wear, prevent overheating, protect surface from corrosions. Important key properties of lubricants are viscosity, flash point, and pour point. Synthetic lubricant and specially engineered to work efficiently under high temperature and pressure conditions. Emerging lubricants such as nano lubricants and biolubricants are gaining importance due to their improved performance and environment friendliness. Next, combustions. Combustion is a chemical process in which fuels react with oxygen to produce heat energy. Reaction kinetic studies the rate of combustion reactions. Stoichiometric combustions occurs when the exact gas-fuels ratio is maintained for complete combustions. One major problem in engineers is knocking, which occurs due to uncontrolled combustions. To prevent this, anti-knocking agent are added to fuels. Hydrogen combustion is considered a future technology because it produces only water vapor as a byproduct, making it a clean energy source. Fuel gas analysis is used to measure exhaust gases and control pollution levels. Next, adhesives. Adhesives are materials used to join two surfaces together. Adhesion mechanisms include mechanical interlocking, chemical bonding, classification of adhesives, natural adhesives, synthetic adhesives. The bond strength of adhesives depend on surface condition, temperature, and curing time. Industrial adhesives are widely used in electronics, automotive, and aerospace industries. A practical activity includes studying the adhesions of thermal buds on integrated circuits, which helps in effective heat dissipation. In last course outcome, chemistry plays an important role in mechanical engineering because it helps us understand materials, energy conversion, lubrications, and corrosion. First, materials chemistry helps in selecting suitable materials like metal, alloys, polymer, and composites for mechanical components. Chemical compositions and structure decide properties such as strength, hardness, and durability. Second, thermodynamics and fuel chemistry are applied in engines, turbines, and power plants. Chemical reaction during combustions determine efficiency, fuel consumptions, and emissions levels. Third, corrosion chemistry helps prevent rust and materials degradation in machines exposed to moisture and chemicals. Protective coatings and inhibitors are developing using chemical principles. Then next lubrications chemistry reduce frictions and wear between moving parts. Proper lubricants improve efficiency and increase the life of mechanical system.